Good morning class. Today we will going to discuss about the relationship between electrical susceptibility and dielectric constant. As I am going to repeat this derivation again because of some kind of network issue was there, so you are not able to understand. So let's discuss this. As we are saying that whenever the dielectric is introduced inside the parallel plate capacitor, so what's happened? Reduced electric field will take place, and what will be the value of reduced electric field? That is E is equals to E naught minus EP. This is your applied field and this is the field due to polarization. So we just shift this E naught here and E will be there and like this. So as we know, EP is this much. Okay, so as we know, sigma P can be written as P also, so that's why we will write it like this. Okay, so this equation will become, that is equals to E naught is equals to E plus P over epsilon naught, right? Now, if as we know that the polarization vector having the relationship with the susceptibility also, that is put P as chi E epsilon naught, and this is your applied electric field. Okay, so if this value is going to be put here, what we have, E naught is equals to E plus chi E epsilon naught, and this is E. Epsilon naught and epsilon naught is going to be cutted down, right? So what we have E naught will be equal to, that is E plus chi E, and this is E. So you can see here the E is common here, so you can take it out also, na? So that is why E naught is equals to, that is equals to E 1 plus chi E. You can write like this. Now E naught upon E is equals to 1 plus chi E, right? So this will be equals to how much? As you know that E naught over E will be written as dielectric constant also. So we can write it as K 1 plus chi E. So this is your relationship between the dielectric constant and the susceptibility. As my aim is to find relationship between electrical susceptibility and dielectric constant, and this is the value and this is its relation. Okay, so now we will discuss what we have studied. We have studied that what is parallel plate capacitor, what is the principle of the parallel plate capacitor. So in the case of principal plate capacitor, we have studied that we have to calculate the voltage first, and then we will able to calculate the equivalent capacitance or the capacitance of a capacitor. So let's try to find the capacitance of various kind of capacitor. First is your capacitance of parallel plate capacitor. As I said, there is only two kind of combination. One is parallel plate and another one is your spherical. So firstly we will discuss about the parallel plate capacitor. So let's say these are the two parallel plates. One is having the charge positive Q and another is having the charge minus Q. So that's why its surface charge density is plus sigma and it is minus sigma. Now because here is the positive charges and here is the negative charges, so electric field goes from positive to negative. So this is the direction of the electric field produced inside this parallel capacitor. Now this parallel plate capacitor is going to be separated with the distance d with the help of a medium, but here the medium is not inserted, right? So as we know that the electric field here in this case will be equals to sigma over epsilon naught, right? As electric field is there, there is the potential also there. So potential of the capacitor, as I told you, you have to write the potential in every case where you want to calculate the capacitor. So potential here will be equals to, as you know the relation, that is what is the relationship of electric field with potential gradient? That is equals to E is equals to dV upon dr. So you can write it as V upon d also. dV means small, V means total, dr means small distance, this is total distance. So V will be equals to E d. So V will be equals to E D, right? And here, from here you can calculate the E also, that is V upon D. Okay, now we just put the value of E from here to here. You can write it as 1, here it is 2. Put 2 in 1. So what will you have? So you will put, you are basically, what you are doing, you are putting equation number 2 in equation number 1. So what we have? We have that is equals to V upon D is equals to sigma over epsilon naught, right? So we have to calculate, our aim is to calculate the potential. So that's why that implies V is equals to sigma D over epsilon naught. Now we have calculated the V. Now what we are going to do is, we write the capacitance. We know that by the definition of the capacitance, that C is always equals to Q by V. Q is same, but V is from here sigma D over epsilon naught goes up. Okay, and this way it will happen. Okay, so if I'm going to write sigma as Q by A, as you know, the surface charge density is Q by A. We just put this value here. This is third, this is fourth. Put 4 in third. Then what happened? You will have C is equals to Q epsilon naught sigma A ऊपर चला जाएगा D. Okay, like this है ना. This is Q by A, sorry, this is Q. So Q and Q is going to be cancelled, and what you have capacitance of the parallel plate capacitor as C epsilon naught A and D. Means capacitance of a parallel plate capacitor depends on the area directly. That means larger the area, larger will be the capacitance, and inversely proportional to the distance between them. Matlab, if the distance is going to be increased, capacitance is going to be decreased. In this way you will calculate the capacitance of a parallel plate capacitor. Now capacitance of spherical capacitor. Capacitance of spherical capacitor. Now spherical capacitor, as I told you, there are two kind of arrangement. One is parallel, another is spherical. So let's say this is your sphere. Okay, this is your center of the sphere, and here the charge Q is present. Let's say the point where you have to where they have to calculate the capacitance is somewhere here. Let's say P. This is the distance, this is the radius R. So firstly we will write the potential. As we know that the potential at a spherical shell, if the point lies on the surface, is given by V1 over 4 pi epsilon naught, and that is Q by R. This is the potential. Okay, so we easily know this potential because we have already known it by the earlier, we have discussed it. So C is equals to Q by V. Put this value of V here. This is Q, this will be equals to Q 4 pi epsilon naught, यहाँ shift हो जाएगा, and R will also, so Q से Q cut, so C will be equals to 4 pi epsilon naught R. Or you can say this is the constant. That means capacitance of a spherical plate capacitor depends only on its radius. That means more will be the radius, more will be the capacitance, more will be the ability to hold the charge over a body. Clear? So this is your capacitance of a spherical capacitor. In case of parallel plate capacitor, it is epsilon naught A upon D, and in the case of spherical capacitor, it is 4 pi epsilon naught R. Okay, so this is what we have done. Now next is your capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor with dielectric. Now that previously what we have discussed, that is your parallel plate capacitor but without dielectric. Now here it is the case where the dielectric is introduced between the parallel plate capacitor. So let's say these are the two plates. Okay, now this carrying the charge as positive, and this is your negative. Okay, this is via P, you can say this is via Q. What you have to do is you have to insert the dielectric. As you insert the dielectric between them, then what happens? Due to the induction or due to the charges get polarized, this end of the dielectric will attain the negative charge, and this end is negative, so that's why it will become as the positive 1. Now one field is applied by you, that is your E naught. Okay, and the another field is created due to the charges of the dielectric, so that is electric field due to polarization, as we have discussed it all. Let's say that thickness of the dielectric is T, and this distance with including the parallel plates, that is D. Okay, so as we know that capacitance of a parallel plate capacitor is given by epsilon naught A upon D. We have calculated it now. Okay, now as dielectric is introduced, what happened? The value of the electric field is going to be reduced, as we know that whenever the dielectric is introduced, electric field is going to reduced. Okay, electric field is reduced, then by how much amount it is going to be reduced? We can write it as E is equals to E naught minus of EP. We can write it like this. Okay, now this E naught minus EP कहाँ exist कर रहा है? This will exist inside the dielectric, तो exist in region T, having thickness T, you can write like this. Okay, whereas this E naught will exist in, E naught is the applied electric field. अब यहाँ तो already you have inserted the dielectric, so this portion remained. This portion is how much? Now this whole is D and this one is T, so this will be equals to D minus T. Okay, so E naught is exist in region where exist in D minus T. Okay, so our aim is to calculate the potential. V is equals to ED, as we know. So V is equals to, here we have two regions, so that's why we have to write it differently. So firstly is this one region, that is E naught D minus T, plus one is this, and another potential is developed inside the dielectric, so that is E and this is T. Why E? Because this is the electric field inside the dielectric. Okay, so here what we are going to do is, as we know dielectric strength is E naught upon E. So from here if we are going to calculate E will be equals to E naught by K. Right, we just put this value here. So V is equals to E naught D minus T plus E naught by K, and this is T. Okay, now what you are doing, you will just take out the common things outside. So we have D minus T inside plus T by K. What we are left with? We are left with this. Okay, now this is V upon E naught. Okay, now as we know that E naught will be equals to sigma over epsilon naught. We know this thing that whatever the electric field inside the parallel plate capacitor is sigma over epsilon naught. If we put sigma as charge by area, so we have like this. We put this value here now. So V will becomes Q A epsilon naught, and here D minus T plus T by K. Okay, this should be no problem. Now this is the potential. As we want to calculate the capacitance, C is equals to Q by V. Put the value Q as it is. V is Q A epsilon naught goes upside, and this will remain in downward direction. So we just write like this. Q and Q will be cancelled out. Okay, so what you have? C is equals to A epsilon naught. This is D minus T plus T by K. This is what we just remain with, but this is not it. We have to simplify it further. Okay, so again we are going to simplify it. So what we have? We have C is equals to A epsilon naught D minus T and T plus. What we are going to do is we just take the D outside. If we are going to take the D outside, then we have 1 minus T upon D and plus T. Here K is present, T is not there, so we have to divide it by D. Okay, now this is your equation number 2. Okay, so divide equation 2 by 1. This is your equation 2, and where is the equation number 1? That is the first one equation. So that means C over C naught. So this is A epsilon naught D 1 minus T upon D plus T K D, and C naught is A epsilon naught D, no? So if it is in denominator, so it will get reversed like this. This and this is going to be cancelled. This is also going to be cancelled. So we just remain with C is equals to C naught 1 over 1 minus T by D plus T K D. Now this is in bracket, remember this. Now C upon C naught will be equals to 1 minus. If we are going to take the minus outside and T by D as the common thing, then what we will have? T minus D. This is 1. Minus is taken outside, so inside the minus will be stays. And T upon D is taken common, so here we have 1 minus K. Okay. So we will multiply here by it. C naught 1 minus T by D 1 minus 1 upon K. Okay, you know that the dielectric constant is also written as absolute permittivity or relative permittivity, ER. So that's why we are going to replace it. C is equals to C naught 1 minus T by D 1 minus upon ER. Okay, so here what you can conclude is this is your final expression of the capacitance in case of the dielectric medium. If the dielectric medium is there, then the value of the capacitance is calculated with the help of this formula. So from here you can easily conclude that C is always greater than that of the C naught. That means capacitance of the parallel plate capacitor with dielectric is going to be more as compared to the capacitance of a parallel plate capacitor. Now cases will be there. If dielectric slab is exactly equal to the distance of the parallel plate capacitor, then what happens? You just put this value here. So we have C is equals to C naught. This will be equals to, that will be cutted down. D and D, that is 1. 1 minus 1 is again 1. Okay. So here we have only, or you can put it here. Okay, give it equation number 3rd. So from 3rd you can write, from 3rd. So you are going to put it 1 and 1 ही रह जाएगा, right? So what we have only 1 upon K. So that comes out to be Kc naught. That means capacitance increases. In that case, capacitance increase by factor K. मतलब dielectric constant से increase होगा. Or you can calculate from here K also. K in terms of capacitance is always equals to C upon C naught. Okay. So if another case is taken, that if T is equals to D by 2, you just have to put it here. So C upon C naught will be equals to 1 minus, that is 1 minus D upon 2D, and this is 1 minus 1 by K. D and D is going to be cut down. Okay, so what you have remained with C is equals to C naught 1 minus 1 upon 2, and this is 1 minus 1 upon K. And when you will simplify it, you get that is 2kc naught, because LCM will be 2k, 2kc naught, and this is K plus 1. This is the expression in that case. Okay, similarly you can put the various kind of distances and you can calculate the value for of the capacitance for different kind of ranges here, right? Now next is your effect of dielectric constant. What is the effect of the dielectric constant? When dielectric constant is induced or put it inside the parallel plate capacitor, then what happens to the various parameters? So let's discuss various parameters that are going to affect that changes on introduction of dielectric slab, on introduction of dielectric slab. Okay, so let's say that dielectric is introduced in between the parallel plate capacitor. These are the parallel plate capacitor. This is positive, positive. This is negative, negative. And here the dielectric is going to introduced. Okay, this dielectric is having value K. If it is introduced and let's say the battery is connected between the plates here, what is happening? Battery is also going to connect here. That is V. Okay. So in this case, whenever the battery is connected, the potential across the plate is going to be same. Remember this thing, potential is not going to change. If you applied the potential of 5 volt, then potential remain same. That means if you applied V as 5 volt on introduction of dielectric slab, here it will remain as same. Okay, electric field is also going to remain same. Why? Because as we know that there is a relation of potential and electric field, that is equals to E is equals to V by D. So if V is same, V is equals to V naught, or D is same, then it can be written as E naught also. That means it is going to remain same. Third factor, either the capacitance is going to be changed. As we know, C is equals to Kc naught. Okay, that means if capacitance is going to increase, the final capacitance is also going to be increased. That means it will increase here, right? So whenever the battery is connected and the dielectric plate is placed in between the parallel plates, the one factor that is going to increase is capacitance. And the charges Q is equals to CV. Okay, so CV, C can be written as Kc naught and V can be written as V naught. So that means charge is also going to be increased. Okay, charge will also going to be increased. So on introduction of dielectric slab and the batteries if connected, then only two things are going to be changes, that is your charge as well as your capacitance, and potential and electric field is going to remain same. If now second case, if battery is disconnected, the case we are taking, if battery is disconnected, this is not applied, yani V is equals to 0, then charge remains same. Firstly, Q is same, it is not going to change. Potential is going to change as V is equals to V naught by K. Okay, so it is going to decrease. You have to remember these things. Okay, capacitance will remain same, it is going to increase here also. Either the voltage is applied, either the voltage is not applied, capacitance is going to increase. Why? Because C is equals to Q upon V and this is K, Q naught and this is V naught. Here we have put the value here. Okay, so that comes out to be K, Q upon V is C naught. It is going to be increased. Electric field, E is equals to V by D. What is V? V is V naught by K. So KT. So because we are saying that the potential is decreased, if it is decreased, then what will happen to the electric field? It is also going to be decreased. So here it is also going to decrease. So these are the factors which are going to change when the parallel plate capacitor is going to connect with the battery or not connect with the battery. So I think it's enough for today. Thank you and have a nice day.